Hey everyone, and welcome back to Retured. I'm Amy, and today we're pulling back the curtain on a bit of AI magic. Ever typed, "Write me a haiku about mangoes" into an AI app and wondered how it conjures up those perfect 17 syllables? Well, beneath that glittery UI often sits a humble hero, the probability mass function, or PMF. Think of it as your AI rolling a 50 billion-sided die with weighted faces to pick the next word. Intrigued? You should be. Let's decode it. So what's our mission today? We're going to understand this PMF, this special map AI uses to navigate a world full of countable choices. We're talking things like, will a user click this ad, yes or no? Or, how many stars for this product? 1, 2, 3, 4, or 5? Not how much do they like it on a scale of pi to a unicorn's dream. We need concrete, countable stuff. By the end of this, you'll get how AI makes these precise bets. Alright, first things first. To get PMFs, we need to meet their best friend, the discrete random variable. Sounds fancy, but it's just a placeholder for a number that pops out of some random process. If that number can only be specific, countable values, like the number of delicious samosas you're about to eat, you can't eat 2.7 samosas, right? Unless things get really messy. Or the number of unread emails that show up in your inbox each morning, then it's discrete. This is different from continuous things like your exact height, which can be any value in a range. PMFs, they're the rock stars for discrete stuff. Okay, drumroll please. Let's bring out our star, the probability mass function. The PMF, usually written as Px equals x, tells you the exact probability that our discrete random variable x takes on a specific value x. So if you're asking, what's the chance I roll exactly a 4 on this die? Or what's the probability exactly 3 out of 5 users click the buy button? The PMF is your answer, genie. It hands you the probability. No fuss, no muss. Now, every self-respecting PMF lives by 2 golden rules. Rule number 1, no negative vibes allowed. Probabilities can't be negative. You don't have a minus 10% chance of sunshine. That's just pessimism, not probability. Rule number 2, it all adds up. If you sum the probabilities of all possible outcomes, they must equal 1 or 100%. Think of it like a pizza. All the slices make one whole pizza. If not, well, either your math is quirky or someone's eaten a slice of reality. So how do we see these PMFs? Most often with a good old bar chart. The horizontal x-axis shows all the possible discrete values our random variable can take, and the vertical y-axis shows the probability for each value. The height of each bar? That's your P of x equals x for that specific outcome. Nice and clear. PMFs are the heart of many famous discrete probability distributions. Let's meet a couple. First up, Bernoulli, the ultimate yes-no decider for a single trial. Think, will this user click this one ad? That's Bernoulli. Then there's its ambitious sibling, Binomial. If Bernoulli is one coin flip, Binomial is flipping it, say, 10 times and counting how many heads you got. Python's scipy.stats makes playing with these super easy. Next in our PMF Hall of Fame, Poisson. This one counts how many times an event happens in a fixed interval, like emails per hour or customers arriving at your favorite Mysuru chaat stall in a minute. And finally, the fairest of them all, Discrete Uniform. Here, every outcome has an equal chance, like rolling a fair 6-sided die. Again, Python and scipy.stats are your best friends for exploring these. Okay, so PMFs are cool for stats nerds, but why does AI have such a massive crush on them? Well, it's more like true love. In classification, when an AI decides if your picture is a cat, dog, or maybe a very fluffy idly, its final Softmax output is a PMF over those classes. In natural language processing, predicting the next word, that's a PMF over the entire dictionary. Reinforcement learning agents choosing an action? Often a PMF. And those amazing attention mechanisms in transformers? They use PMFs to highlight which words are most important in a sentence. PMFs are everywhere in AI. Now, let's talk about where PMFs really throw a party. Generative AI. This is the AI that creates new text, music, even code. When it's building these things one discrete piece at a time, like one word after another, PMFs are the engine making it happen. I like to call it next token roulette. So how does this roulette work? First, given the text so far, the AI model computes raw scores called logits for every single word in its massive vocabulary. We're talking tens of thousands of options. These logits then get zapped by the Softmax function, often with a secret spice called temperature or T. This transforms them into a beautiful PMF, telling us the probability of each word being the next one. A high temperature makes the PMF flatter, making the AI more creative and random. A low temperature makes it pick more obvious words. Once it has this PMF, the AI doesn't just pick the single most likely word every time. That would be boring. Instead, it samples from this PMF. It's like spinning that weighted roulette wheel. This introduces useful randomness. But to stop it from going completely off the rails, like ending a knock-knock joke with platypus because platypus had a tiny chance, we use smarter sampling tricks like top K, which only considers the K most likely words, or nucleus sampling, which considers the smallest set of words covering most of the probability mass. These keep our AI coherent, mostly. Now, working with PMFs in AI isn't all smooth sailing. Here are a couple of banana peels to avoid. First, thinking tiny probabilities are safe to ignore. Nope. In a huge vocabulary, many tiny chances can lead to unexpected, sometimes problematic outputs. The tail of the PMF matters. Second, mixing up PMFs and PDFs. Remember, PMFs are for discrete, countable things like word choices. PDFs are for continuous things like height. They're as different as a refreshing glass of tender coconut water and a shot of espresso. And one more common trip up. Believing that because Softmax makes probabilities sum to 1, your PMF is automatically correct and useful. Not quite. Softmax is a great normalizer, but if your AI model produces garbage raw scores or logits, then Softmax will just give you a perfectly valid PMF of, well, normalized garbage. Good PMFs come from good models and good training. So there you have it. The probability mass function, from humble dice rolls to powering that sophisticated next-token roulette in giant AI models. It's a cornerstone concept for handling discrete uncertainty, and it's absolutely fundamental to how AI classifies, pays attention, and yes, how it gets creative in generative tasks. Understand the PMF, and you understand a huge piece of what makes modern AI tick. Phew, that was a deep dive. Has learning about PMFs, temperature, and sampling tricks sparked any new ideas for you? What common AI pitfalls have you encountered? We'd love to hear your thoughts. Drop them in the comments below. And of course, if you found this useful, please give us a like, subscribe to Retured for more AI insights, and visit us at retured.com to see how we're helping bridge expertise and AI. Thanks for watching, and I'll see you next time.